Good evening, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Gumbus. Oh, shouldn't eat that fast.
Yeah, I know. I slammed down my dinner too.
Yeah, it was heating it up, and I didn't realize that the hotel refrigerator, I didn't feel like I was getting cold, and I didn't want my food to go bad, so I turned it down to like negative whatever. And I pulled out my ready-made meals and find out that my green beans are frozen. A little bit too much. A little bit too much. So what's going on with you?
Oh, just trying to stay busy.
Yeah. What were you doing? What were you doing today?
Today, what did I do today? Oh, I went downtown Chicago to a store that's in a high rise that every time I go to, I'm just like, ugh, this place again. There's nowhere to park. Like you got to park like 5 blocks away. So did that, program, cut a couple system switches in for guys, programmed a couple circuits, pumped down a couple systems, then shot out of there to go help some guys finish up on a remodel, just pumping some stuff down, just trying to stay busy. Like it'll like lull for us, like we just hit this spot where we're waiting on a bunch of cases and waiting on a bunch of condensers. So 2 more weeks, it'll probably be like busy as could be again. But so I don't know, it's been nice somewhat to get 40 hours a week, but then I'm like, yeah, 40 hours a week is disgusting.
The paycheck isn't really making you happy, right?
Oh, God, no. I'll take my 50, 55 hours. 50 hours is like my sweet spot.
Oh, really? That's why I started taking off Fridays. Every Friday that I'm home, I shake off the day because I didn't ever realize this, but I always leave on Sunday if I have school or trying to do something. So basically, I'm working 6 days a week. So I was like, why am I doing this? So I was like, hey, I'm going to start taking off Fridays. Just make it a little bit easier on me. I'm exhausted. It's day 2 of the second CO2 class, and I'm smoked. I didn't sleep well last night. I kept getting up in the middle of the night, so whatever.
Yeah, I don't know. I'm pretty wore out too. Been working on a lot of stuff that you've been having me work on, so like it's been like every night.
Making headway though, I see.
Yeah. So tonight I wanted to talk about, guys, something that like gets brought up every job and it's always an afterthought and then complaining and like, why the hell didn't we do this? So this is splitting of CO2 gas coolers. Why is this not done? Okay, down where Brett lives, I see no point in it.
Like, it's not all right. Maybe you're kind of
right. Okay, from the Mason-Dixon line down, I pretty much see no point in it. So but above, like into Canada, like we run into this problem nonstop. Every time it gets below like 40 degrees, these racks just run like god awful because these gas coolers are so oversized. Well, and go ahead.
No, I was going to say, because this guy said something to me today. He lives up in Wisconsin. And he was asking me, so why does this happen? Like, why does my stuff basically shut down and like off? And I'm like, depends on the customer. There's a couple of different reasons why, because they basically get no load because they end up doing stuff like strip or pull down curtains and stuff like that. But if they had, he just said, I just couldn't even get the rack up and running. I was like, technically, if the rack starts under a dead stop, it's just that cold where it's negative freaking whatever outside, it should eventually just bring on. But he said he was just having it where it was stalling out. And I was having the same conversation that we talked about before where, look, Canada has 1 temperature band. Their shit's designed for the same stuff, right? In Europe, 2 temperature bands. And then we have the United States here where everyone thinks one size rack fits all. And it comes down to there needs to be, I think, more. And I know you agree. We need more options for these different colder and warmer climates.
Yeah, 100%. Like splitting the condenser. There's a couple ways to do this. There's splitting the condenser. There's bypassing the gas cooler altogether, which I'm not like a super fan about. Like I see way too much negative with bypassing the gas cooler altogether. I feel like there's more room for error with that one. I'm a big fan of splitting it. I think we should start splitting these gas coolers up, especially the V-style ones, especially for example, the Gutner ones where they're double row fans. You could split down the center, split the one side off, shut those fans off, save that energy, cut the gas cooler in half, And now you have way less heat being rejected at one time. You could run more steady fans, and it would leave for an all around more steady rack. Because what happens is when it's cold out, that fan kicks on for a split second. That drop leg temp, especially if you're controlling off drop leg temp for your fans, that drop leg temp instantly hits, starts this downward spiral of fighting the high pressure valve, and it just runs god awful. And then we end up with this stalling situation because we can't keep things running because the flash tank pressure is all over the place, and we're just hunting nonstop.
So I have a question, since we're talking about gas cooler and gas cooler control and that. What do you feel about, do you think it's better to Modbus everything together and have it controlled where, because I know we talked about a little bit where Gutner has their set point in there that if it runs low enough frequency for X amount of long, it basically just says, hey, we could start shedding off some of this? Or do you think that we should basically be able to do just analog output signals and like one row and one row for essentially non and regular split side?
I'm a big fan of keep it simple.
I agreed. All right.
So I like the control. I like the Modbus aspect of it for monitoring, so you could see everything that's going on. But I want it simple. I want to be able to. I don't want to have to talk a tech through. Hey, this Modbus point is written to this. I want to be able to say, hey, grab your meter, put it on DC volts, and put it here. What do you got? What's the fan doing? So it's like that to me, that's a lot simpler. 2 analog outs, and then have the integration to monitor. So that way we can shut down like half the fans. Because here's my thing with, especially with the Gutners, has been a big pain point for me. You need to be able to shed fans, and without using the LCM or anything like that. I don't want that. I want to be able to tell a fan to shut off, and I want to be able to run it like minimum percent with one fan. I don't want the other fans on. So say whether they do it on outdoor ambient, like obviously if we're writing to it, we could shut it down. But as it stands right now, I think there's only like 4 or 5 digital inputs on there. If you had a 5-fan gas cooler, you may be able to break them down to be split and not non-split. But as it stands right now, like we need to be able to shed those fans off there. So we need to be able to go down to one fan, because that's all we need in the summertime. And then, or I'm sorry, the wintertime. Summertime, if you really want it, get fancy, just let some reliefs blow. But in the wintertime, it's all we need. Like these gas coolers on most of these racks are so oversized for the condenser for summer gas cooler operation that they just run like god awful in the wintertime.
I think maybe doing I'm a big fan of the 10 volts for off and 0 volts for 100% on. And then I like it that way because in case you do lose your analog output, you're not totally screwed. I also like the fact that like you can put whatever energy management controller you have in there and then essentially be able to start shedding fans, and you'd be able to write a program, no harm, no foul, quickly based off of what you have to do. We'd want to typically turn it off, turn half of it off at 60 degrees or whatever, maybe 50 in your area, and then basically go from there. And I don't know, do the same thing like what we do with the SVS, single speed, variable speed. So you're controlling everything, and then just hell, you could write something that, hey, if it goes, you could put it in a loop sequencer. You could have it where you have it turn on if the next fan has been up to 100% for X amount of length. There's so many different options that you could do, and then you have that more precise control. My question is to you though, like when you're only running half the bank, because I don't remember, there is a divider between one side and another, yeah?
Yeah, there should be technically a divider in there.
That's what I'm saying. So I know like on a regular conventional non-adiabatic gas cooler, you're going to have that, right? You're going to have the divide, but the V style, I'm not sure if I don't know. I never really looked. Is there a divider in between? Because that's the only thing I'd be concerned about with, especially at the higher the end of the ambient, right? We're being able to shut that down, because if you're potentially pulling air from one side out through the other, your fans might not have enough pull, right? Because it might be pulling from the open portion of the actual, fans that aren't running currently. You know what I'm saying?
Yeah, but in the interim, like that, think about it like this: if you were doing that, it would derate it even more a little bit. You would still be pulling from that area, but like you would It'd be like the Guttner mode where it spins the fans backwards, which I've never really seen. I've never really seen anybody use it, like where it spins the fans backwards to try to keep the heat inside the condenser. It would be just like the same thing. Like it'd be doing less work. So that one fan would be doing less work because it'd be pulling through that whole gas cooler.
Is there, and I need to look, because what manufacturer of
Guttner, I'm almost positive is split down the middle.
No, that's fine, but what manufacturer of oh my god, my brain is fried. The gas cooler fans, are they empaths or what?
They're impact, and then they're the Heil, whatever they
don't say it. Zeal Abeg.
Whatever. Like they made the worst name ever. Like it's pick a name that somebody could say.
You know how much I did if I never told you that I hate you?
Yeah, you tell me all the time.
I'm just telling you.
So yeah, I don't really care if it pulls through. We lose a little bit of kW from that, but we're gonna save energy by shutting down that whole bank of fans. You save more kW on keeping the rack steady and cutting out the hunting than you are gonna save by whatever little fan horsepower you're gonna lose by letting it pull through. I know that whose towers are they? Who makes the BACs? They're not split down the center, and they say you're not supposed to split them. I'm here to tell you, I've split plenty of them, and we have zero issues.
So I will tell you, like I had a problem. There was a customer that had a split. It was a Cascade rack, and I know we're talking about CO2, but I'm just telling you the problem I had. One, they didn't have any kind of restrictor, like no pilot line. It was just a 3/8 line, just hauling ass when it would go in the split on the one side. The other problem is because they couldn't shut down. I think it was a single fan bank, so they could only still have the fans running, and then essentially the liquid would just disappear out of the receiver, and it would just hang out there. You know what I mean? Like even with pumping it into the suction. How would you mitigate that though? That's the only thing that kind of frightens me.
I would use an SCR valve. Use an SCR valve, like a AA SCR valve, and then maintain superheat. So the entire time, if it starts getting the superheat too low on the leaving line, shut the valve down a little bit during the pump out. Very easy.
That's my point, though. If we still keep rolling the freaking fans, I guess it wouldn't matter, because as long as you
get the gas out, you're done.
Yeah, you're fine, because so essentially, as long as you wouldn't split it at 32 degrees, if we ran it how we thought about running it and put it directly in the gas cooler, yeah,
as long as you ran how we're talking about, and you split it, say you split it 50 degrees. Okay, you split it 50 degrees, get it out of there. Now you're going to be running more fans on the other side. You may be running one coil with 5-6 fans, but you're going to be split at 50 degrees, and you're going to be more loaded up on that side of the gas cooler. So you're going to get a more even flow through that gas cooler, and you're going to get a more steady flow, and the whole rack is going to run better. You save more energy by keeping oscillations and keeping the rack running efficiently and without hunting than you would be by having that gas cooler running with the other side running. I'm a big proponent of this, and it'd be fairly simple to do this. Like the more I look at it, okay, and they should be doing this, like on doubled gas coolers. So like on V-style gas coolers, they should be putting ball valves on the inlets and outlets of the coils. So think about it like this: you got a leak on one side of the gas cooler. Okay, you could be running the other side of the gas cooler still on the other coil, and you could be servicing the other coil. I don't know why people aren't doing this. Like this is, you're talking like an extra $200-300 worth of cost to put 2 ball valves in. That's nothing in order to keep this thing running. So that way you could still run half the gas cooler. And here's the other thing. I'm looking at it this way. So you got 2 you got 2 ball valves up top for discharge, 2 for the returns, and you'd have to have 2 check valves. So you don't want the gas going backwards in through there. So you'd want a check valve. Okay. So just like you would split a normal rack. Now, you'd obviously probably need a relief here so you don't trap liquid. It'd be the only downside is you need to put a high pressure relief on there, which I don't really see that being too big of an issue. So you add a relief, whatever. But at this point, you could easily add a BLEMO valve to the discharge of the split side to pump it out. Or you could do a stepper valve. You could do like a CDS valve for it, a high pressure CDS valve for it.
I'm in disagreement with you on there.
Why?
Because there's more of a chance of having a stepper valve fail than I think a motor actuated BLEMO.
Oh, the motor actuated BLEMO is going to fail every time before it, but you can still shut the ball valve off. Those motors are super unreliable.
I guess it depends on how many times you cycle, right?
You look at them wrong, they fail.
But I don't know. Stop. Like, why?
But
I'm just dreading the fact that I have to call somebody from over there now for information. So thank you for that.
They don't care about us. We're like one smidgen of their business. They
No, but what I'm getting at is like at least their spring return, right? So you can spring return. You could put a spring return type. Okay, so maybe not a BLEMO valve.
How is the spring return going to open a ball valve?
You don't think so?
No, not those discharge ball valves. Those things got a lot of tension on them.
All right,
those stainless Italian ball valves, those things don't move, especially the discharge ones don't move that easily. Yeah, could it be spring return? I'm sure they have some crazy spring return stuff, but most of the stuff we see is power return.
Okay, so, power return. It would. You don't think it still could open that thing up?
I think it could open it up if it was power return. Yeah,
that's what I mean.
Yeah. Is it probably more fail proof? Probably. Could you do it with stepper valves? Yes. The only thing I don't think we have at this point are CO2 rated solenoid valves, like high pressure solenoid valves. I've never seen one. I'm sure they exist in Europe somewhere.
No, but I don't know. I would want something modulating. I don't think I would want a solenoid because going from X temperature, X pressure, like flash tank pressure, let's say it's at 490, right? And then you just kick on a solenoid. I don't think I'd dig that. I'd want a slow open or a repressurization that one company does, but not do it with a solenoid, but do it with some kind of SCR, bipolar, something. I just don't know how I feel about not having that auto return in case, God forbid, something happens, temperature sensors off, whatever.
Yeah, I get it. I would want it like a repressurization easy. I wouldn't want to hit it with, say it gets to 60 degrees and we're running a 1,000-pound discharge, or like we go into like a high head situation and we're going to blast it with 1,400 pounds of head when it goes into fast reclaim. I wouldn't want that. I would want it to, be a slower open. So if you were using a BLEMO, like a 90-second actuator, so like it's 90 seconds from open to close. So that way it has a little more run time.
So you probably could maybe answer this for me, unless I just got to try to get a hold of female Brett. You listen, you were the one who said it and I didn't say it. No, I'm wondering. So obviously you have the 0 to 10 volts. Are you still laughing? 0 to 10 volts on the Epic fan motors, but I'm wondering if there's any kind of DI that'll actually swap.
I'm sure there is.
I'm looking it up now. Do you have a model number or no?
I don't. Some German numbers.
No. Oh, here it is. 1,
So they're German. Motors made in Mexico.
Go ahead and continue.
Yeah, I'm sure there's some kind of DI you could put into those. You could definitely Modbus them and shut them down probably. But that's a big thing. That's another problem with all these gas coolers that's why I like the Reef Plus gas coolers, because they usually just run all their AO wires separately back to a terminal block. And theirs are super easy to rewire because you could take those and just daisy chain them.
What they were doing when I got to tour the place up there, they had their number one is a 0 to 10 fan. And then all the rest of their fans on the gas coolers are two speed fan.
I don't like that. I like every fan. If I'm gonna have ECM motors, I want every fan to have them, because that's where you're saving your energy. I don't want fan cycling. To me, to be honest to you, I'd rather have 1.5 horse motors in a drive controlling it. I think we'd be a lot better off. From a sustainability standpoint. I think having standard condenser fan motors, like horse and a half motors, we would be better off than these ECM motors, because when these fail, they're very hard to get. And I'd rather go to a supply house, get a horse and a half motor, and have a standalone VFD and contactor cycling it like we've done for 30 years. I think that is a way more sustainable way to run these gas coolers than we are right now. But everybody wants these ECM motors.
You sound like a boomer.
They're like, the problem with them, they're hard to get. I can't go to a supply house and get a motor when it's burned out. I go up there with a Harbor Freight fan, you putting it on top and letting it blow. I'm serious. The Harbor Freight fans is like the same size as those EBM PAPS motors. They fit right on the volute.
On the what?
The volute.
What's the volute?
The cone.
I've never heard of a volute. Sound like some German term.
I hate you so much right now.
I'm just saying, like you said, what?
So
I can't believe you don't have a model number for this freaking
I don't remember I'm not Rain Man. So that's my problem with that. But yeah, if I'm going to have ECM motors, I want them on every one, but I want them to where I could split them up. So like I could wire them to an RO. And what I do with them is I will put the motor on the common. So the positive feeding the motor on the common of the relay, and I will feed the normally closed. I will feed it my DC signal, and I will feed the normally open 10 volts, 10 volts DC. So that way, when it goes to shut a motor off, the relay will open up, the normally open will closed, and it'll send the 10 volts to the motor to shut off. That is the easiest way to split these ECM motors up, for you to have one signal wire controlling them all, and then just cycle them on and off. That alone just gives you so much more control over these gas coolers. But then you need to split when you have the ability to split, which is only on the V style right now.
So I have a question. Have you ever seen any of the Zeal Epic or any of the Impasse ones like blow apart more so than what the conventional ones are?
I've seen the blades come off one time.
So that's what I'm wondering. I'm wondering if, because that really doesn't happen with these very frequently, I'm wondering if that's really the deciding factor on whether they're doing that or not. You know what I'm saying? Dread the day that ever happens to a poor soul. You know what I mean?
Why? What's wrong? What do you mean, poor soul? Like,
no, poor soul. If someone has to fix if it's a stainless steel coil and something blows apart,
you're not like that would be a nightmare. You're pinching tubes at that point.
That's what I'm saying. God bless the poor soul that has to do that shit.
Yeah, it's I don't know. The winter control, I'm definitely a big fan of at least breaking up the gas cooler fans right now. Everybody besides Gutner, it seems to be an option on. The BACs, I haven't really messed with too much of the BAC gas coolers. We have very few of them. I know they get the Corel controller in there. There's got to be a way to stage those ones down.
I mean, I haven't really had any, and I know you're going to say you haven't been in the field for 2 years, but like when I was there wasn't really, we didn't really have a lot of failures on the BAC.
Just the water pumps.
Just the water pumps. I get it, because it's recirc.
Yeah, I mean, the water pumps are water pumps. It's not a traditional tower water pump, so it's not as heavy duty, but I know that we've had a lot of problems with guys having to shut one or two fans off in the wintertime because they hunt like terribly. Now, I don't know if in that Corel controller you could switch it to that to where it doesn't do that. I'm sure you probably could put in like a DI to shut down the fans. There's the room on that board to do it. I'm sure it's possible. There needs to do the same thing.
If you had a model number, I'm just going to say that.
For what?
I want to look up the Zeal Epic freaking thing in the back.
I don't have a model number. Like, you're in the office every day. You should figure it out. Why don't you have a model number?
Because I didn't need one up until right now.
I'm sure they have a DI that can be used for shutdown. I mean, I'm sure they do. But at the end of the day, like, I like doing it with the signal wires because I like to be able to run them through relays. I'd rather have an 8RO board in there or a multiplex board in there that's getting the signals through them. And you can do the same thing with microthermal. You could wire it up like that too. Same thing with Danfoss. So that way when the it calls for the fan to shut off. You have fan cycling and you have variable speed control. You have the ultimate of both sides. But then also splitting the gas cooler is another big, huge advantage. Now, I want to talk about the next thing is I haven't seen this in person yet, but I've heard people talk about it. I've heard a bunch of manufacturers talk about it, is bypassing the gas cooler altogether. So when it gets to a certain temperature, I see some benefits to this, like low load situations, like an Aldi, where they have like in the middle of the night, they don't have much load because you got all the nightshades down. You only have a couple medium temp cases, and then you have your big walk-in. It's all closed up. Lights are off. Boom, load's gone. It goes from load to no load, half an hour. So what there's rumblings about Hill and other people, I know Zero Zone's tried it, is bypassing the gas cooler altogether. So they're using a three-way valve, and instead of taking the discharge gas when it's colder out, lower head pressure, like you're in like the 600-700 pound head pressure range, and they're dumping it into the flash tank. Now, there's a lot of room for error with this, because if the flash gas bypass valve doesn't open up fast enough, if there's a staging issue, you're putting a lot of heat in there real quick. So there's a lot of liquid to boil off real quick. You could end up in a situation where you're blowing reliefs. The other thing is it's a huge waste of energy.
Yeah, you could be utilizing it for something else.
Yeah, I think it's a huge waste of energy.
So let me ask you a question, because you talk about this a lot up in your area. Obviously, all these does use heat reclaim, right?
Yep. So the next thing I was wanting to get to.
But okay, sorry. Continue.
Yep. So like, why bypass the gas cooler into the flash tank when you could just bypass into the heat reclaim and just bypass the gas cooler altogether and use the heat reclaim when the RTU is running to heat the store? Yeah, obviously there's going to be demand issues with that. So if the store gets a little too warm, but I'd rather in the wintertime heat the store up a little more and store it. So if you get the store up to 73, 74 degrees, I mean, who cares?
Can we open up a fresh air damper?
Yeah, absolutely.
Just let some freaking cold air in, man.
But even think about it. Even if you got the store up to 72, 73 degrees with heat reclaim, is that really going to bother anybody?
No, I don't think so.
No, honestly, if it's that cold out, customers are probably going to appreciate it.
Especially if you're warming it up for free.
Yeah, it's free air. You're just using the energy you're using for the fan motor. So it's free air. So instead of bypassing the gas cooler into there, I think that's a horrible, huge waste of energy. That I don't think the penalties were that. I say bypass it into something that's more controllable. Let's let 70-degree air go across the coil and let it run through the gas or through the heat reclaim coil. I think that's an all-around better option. And then bypassing the gas cooler altogether, let it pump out, because obviously you're going to need some kind of pump out. You can't leave that much liquid in a coil. Otherwise, you're going to have problems. You're going to have problems with logging gas if you don't have some sort of pump out with it.
No, I like I said, I'm good with like I said, I'd rather do it to the flash tank, because then you're dumping liquid essentially in there. You do have the pressure difference if you're at 1,700 pounds, whatever. And then you're not, when you go to re-employ that right now, you don't have, one, you're not worried about flooding out the flash tank, right? Because it's mostly liquid anyway at the bottom. And then you don't have to worry about any kind of superheat mitigation, because you're sticking more liquid into there, unlike what you would if you'd have to do some kind of superheat mitigation if you dump it into the medium temp or low temp suction. And then the pressure difference isn't too great when you go to reopen the split valve back up. But yes, I would rather slowly open it up, but at least you have that option there.
I think for sure you'd have to open it up slow. I think if you opened it up too quick, you're opening yourself up to hammering issues. And the way some of these coils come out, like, I would not want to do that. Especially like the way that like all the gas cooler coils are with the headers at the end. Man, that makes me nervous. Like, I would be afraid to blow the header end off if it hammered too hard. But that's where like all these manufacturers are missing the boat here. They're sending this equipment out for one AO signal, or they're sending it out to run like both sides, and it just can't do it. Like they, as a whole, anything like north of the Mason-Dixon line needs to have split involved in it. Like we still need it. Like it's nothing changed from basic refrigeration. We still need split. Like we still need to shed capacity control. We're getting poor condenser operations and gas cooler operations in the wintertime. In the summertime, we're fine, but like in the wintertime, we're so oversized. It's just causing horrible oscillations in all the controls. I bet you a lot of the flash tank issues would go away, and a lot of the oil issues in the wintertime would go away if they would just split these gas coolers and get a little bit better control of fans and change the fan strategy from temperature to pressure.
Ever since we talked about it, that's all. Like even the sequence of operation, I asked one of the field service reps over there. I was like, "Why do you guys even do this?" And just explained to him like what we were talking about as far as it acting like a holdback valve and the fan cycling working together. I just don't understand it. I don't get it.
Everybody's excuse is that's how we've always done it.
Okay, once again, the definition of insanity is doing the same over and over again, expecting a different result. So if we have a problem, let's do something different, right?
Exactly. I'm all for it. Like I have it on multiple sites now, and like we have nothing but good like graphs and stuff. It looks way better than it does when it's temperature. If you look at the temperature graph, it looks like crap. If you look at the temperature when it's controlled off temperature, if you look at the pressure graph, it looks even worse. It's like hunting hundreds of pounds.
Where's your CT? Where's your CT so we can actually measure the energy usage, Kevin? Because then that would be better, and we can write a white paper.
I don't have any of that stuff, so I don't. That's the customer stuff. Like it's above my pay grade, unfortunately. I would love to get some more time on that and like actually spend some more time tuning these to the point where I had CTs to see it. I could just see like the rack smooth out and compressors drop off, and when you're running less compressors, they're hunting. I mean, they're a lot better.
You want to put some CTs on there? I got some CTs.
I have some CTs. But all around, it's a better operation doing it that way. If they start utilizing split and start utilizing receiver bypasses, I'm still on the fence with the receiver bypass. I think it has its place in something smaller. If you're using it like a gas station type stuff, like one of these mega gas stations like Wisconsin has, or like you were using it like a super small like application, I just don't see the energy penalty for doing it. Maybe like a last line of defense, like this thing's about to stall out. Let's get some heat in here. But I don't see from an energy standpoint, I don't see the point in doing it that way. I think that adding heat reclaim to a small rooftop unit and sizing it enough to run the gas cooler load in the wintertime, I think is a far better operation. Why throw the heat outside? Like why? Like leave it inside the building.
Or places like where you're at, man. Like I'm sure there's enough heat to do like snow melting for parking lots. You know what I mean?
Costco did that.
Dude, that would be baller. You basically just heat up I don't think you'd want to do CO2 all throughout, because that's a lot of piping, and then God forbid.
They do is a plate and frame heat exchanger.
Yeah.
In the rack room, they have a this one was an actual plate and frame. It wasn't a brazed plate. It was a bigger one. So what they were doing is they had a glycol skid, and they were running glycol through it. It got in the wintertime, it was kicking ass. Like it took away a lot of heat. So
it took away a lot of what? Sorry, I missed that.
It took away a lot of heat. It did its job, but I don't think it would provide enough for total heat rejection of the system. At least not in those racks. Those were bigger racks. But if you were to actually start heating even a mechanical room, if you're heating a mechanical room, getting it a little bit, get the heat in the building.
Or heating the VFDs too. Apparently.
Yeah, that was a new one this year. That was if you really think about it, that was the first time I ever seen VFDs just hanging in a rack like that, and not in heated cabinets.
I'm trying to figure out what all these. My German is nicht gut anymore. It used to be better.
I'm sure they do, because don't the EBM PAPS motors have a jumper on a DI that you have to have on there for it to be enabled?
So So I'm looking at line voltage, relay out for fault, Modbus. Obviously, if you don't have the script file, you can't do it. Open collector output status. I don't know what that is unless it's sending. Let's see. Open collector output status. It says 20 milliamp max, a feedback loop to tell you actually how fast they're actually rolling. Hold on, let me just bring this up so you can stop laughing at me and actually maybe help me figure this out. I'm telling you, I'm just going to call female Brett. That's what I'm going to do. She was cute.
No, it was scary. It was like a female version of you, and it was like a manic episode between both of you. I'm like, this is concerning.
They were both hyper focusing. No, so you have the open collector, which looks like it's some sort of signal. Digital input for enable. Okay, so you could actually that would be even easier. Like you could just kill the signal for the enable. You know what I mean? Instead of having to run voltage, it's still voltage, but like you could just kill the enable out there. Supply voltage 10 volt DC. Speed setting. This is what I didn't understand, why they have pulse width, and then version of connection cables. So that's all I see. I don't see, and I don't even know if I'm looking at the right ones. Because someone that's in the field doesn't even have it. I'm just taking a guess here. Oh, this thing really wants to get kicked. No, it's freaking, I get some crazy feedback. I don't know what the hell it's from. No, I can't find exactly what I was looking for. Oh, we can't open up the file. Anyway.
I think that'll be it for the gas cooler one, guys. I appreciate you guys listening, and let's try to make a change. Try to force the split.
Yeah, let's get the split back. Make the split great again. Later, guys.